So on 110, we have a description of an ellipse. It's got an ellipse inside of a rectangle. It says the elliptical riding path is to be built on a rectangular piece of property that measures 8 miles by 4 miles. So this distance is 8 miles, and this distance is 4 miles. Find the equation for the ellipse if the path is to touch the center of the property line on all 4 sides. So it means it's touching here, 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 and here, kind of the places that it curves around to help us figure out how far it's shifted from the center. And we're assuming this is the origin. I didn't draw it perfectly to scale here, but assuming this is 0, 0, to get a 4-mile distance here that went 2 and 2. So that means you had, and that's the x distance. So under x squared, you've had going out by 2, which means it must have been a 4 under x squared. Because it's an ellipse, we put plus, and then under y squared, this distance, y distance is 8 miles. So it means we went up by 4, down by 4 from the centering. So that must have been what under y squared? To get the 4, we square root the number under there. So it had to be 16, and then it equals 1. Okay, 111. 111, we have the picture again, and we'll pick the equation that matches this. Looks like it's centered at 0, 0, so there's no offset from the centering. And then this number is a 4 up and 4 down. So that means with same kind of idea as the above. If you go up and down from the center by 4, it had to be a 16 underneath the y. Again, up and down affects the y amount. So under y squared, we have a 16. Now, how do I decide if it's x squared minus y squared or y squared minus x squared? That's that little thing you've got to memorize. If it's an up and down hyperbola, a vertical hyperbola, it had to be y squared minus x squared. So this is the positive part, minus x squared over. And it's really hard to tell exactly what it's over, but you can look at your choices to tell. It must have been over 49 because they have another option there. But that's reasonable. If you moved out by 7s each way and kind of had a box around that and drew the x we do and that seems reasonable, that it could be out by 7s each direction, which would be under 49. But really, it doesn't even matter to the problem because you can pick it just based on knowing y squared is minus x squared because of it going up and down, and that this has to be 4 and 4, which is 16 for the y value, and then equals 1. Let me talk to you about domain and range on this problem, because I know when you did Math Excel, you'd have to say that, address that issue with this type of problem. So if you were to look at this picture and say, what is the domain? For your mind, all you're thinking is, how far do I see any picture of this graph going to the left? Even though there's 2 curves, that doesn't really even matter. If there were only 1 curve, this thing is going to the left and to the right without bounds. So there's no bounds on the wideness of it, or the x values. So we would say the domain is infinity. It's negative infinity to the left, positive infinity to the right. Now the range means low to high. What y values do you see represented? Is there an x value that goes with a y value somewhere along the area? So from negative infinity up to this point at negative 4, we have a graph. We have a picture like at y is, say, negative 6. There's 2 values that go along with that actually. But there are y values corresponding to x values from negative 4 down. There's a graph that you can visually see. So we can say we have a range going from negative infinity up to a high point of negative 4. And it touches it, so I use a bracket. Then we skip over an entire area here, like at y is negative 3, negative 2, negative 1, 0. All these, and I didn't draw it to scale again, so forgive me for that again. I'm not doing a real neat job on my graph. But all this area between here, there's no y value with an x value corresponding to it. It's blank on the y-axis. So we skip over that, and then this value on the picture on your study guide should be positive 4. So the y values pick up at 4 and go on up to infinity. And that's how we state that. All right, number 112, identify the graph. So this is a parabola, but it wants you to be more specific than that. I feel like it's a parabola because y, the largest exponent on y is to the first, and the largest exponent on x is to the second. So you kind of overlook the x to the first. You go by the biggest exponent. Y the first, x to the second. Tells me it's one of these, the second example I have here, a vertical parabola. So I get y equals, try to get it in standard form for a vertical parabola. So the y stays on the left side. That makes it a negative x squared, a positive 7x. So I know it's a downward parabola because of the negative sign. And that may be enough to pick between the choices. Yeah, so you can pick D just from that. But if you needed more information, you could do a t-table, find some points. You do the vertex formula, negative b over 2a to pinpoint the exact spot in the vertex of me. Okay, 113. Alright, so again, trying to identify between the selections over here, the standard form for our conic sections. 6x squared, the biggest x term, the biggest x degree is squared, the biggest y degree is also squared. There's different coefficients, they're both